All right, welcome back, chat. Today we are going to jump in and we're going to start 4.3. Now, just so you guys are aware, if I go through and I'll go all the way back to the beginning of chapter 4, I see that in chapter 4 we have, let's see, 6 lovely lessons. Now, what I intend to do, just so you guys are aware, 4.1 and 4.2, they're pretty chill, nothing too crazy. We didn't do homework in 4.1. When we finish 4.4, we'll have a quiz. We're going to do a quiz on 4.3 and 4.4 together, just so you're aware. Okay, today we get the privilege of starting 4.3. And in 4.3, we are going to be looking at proving triangles congruent. Now, there's going to be 2 sections with the same name, proving triangles congruent. And the reason that there's 2 different sections with the 2 different names is there's different types of shortcuts that we might be able to use. In the bell ringer, what we determined was that if I gave you 3 sides of a triangle and I said they have to be this size, how many different triangles can it make? Just one. Yeah, absolutely. There's only one possibility for it, which means maybe, just maybe, we're already kind of starting to eyeball our first shortcut. So to jump in, our first topic, and can you guys see this orange color okay? Anybody not see this color well? Okay. Our first topic is we're going to talk about what is known as side, angle, side congruence. Now, you will never see me write side, angle, side. You'll hear me say it a bunch of times. This is an every geometry teacher ever thing, not just a me. If you're talking back to your parents, they might say, don't give me what? SAS. SAS congruence, 100%. Now, they might say other stuff as well, but SAS was what I was looking for. Side, angle, side is SAS, SAS. Now, as we go through here, this immediately becomes a wonderful theorem that we get to use. So right off the bat, we're going to give ourselves theorem 4.3, and it's redundant, which is why I'm not going to write it again. We're just going to say SAS congruence. Okay, SAS standing for what again? That's right. Ray, thank you for letting the uncomfortable silence just not exist. Yeah, no, I'm fine with it. I don't mind. I'm good with it, but that's okay. Check it out. Our theorem, you guys are going to help me draw the picture. But we're going to say if 2 sides and I'm going to sneak a word in here, the included angle, which we're not going to define it right here, but we will see it. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle, and I'm not going to capitalize it this time, of another triangle. Then, and I'm going to pause briefly and let you guys catch up. And maybe this was kind of like our bell ringer in a different thing. If I give you 2 triangles and each of them have 2 sides and an angle between them, and we'll clarify that here in just a second, that are congruent, I don't think it's a huge stretch, but what do you guys think we're going to conclude about these 2 triangles that we're talking about that have all these parts that are the same? I'm not going to write they are the same, though. They are, what's the word I'm looking for? Congruent. What was your thought, Andrew? So side, angle, side, definitely congruent. Now, the picture for this, super easy to deal with. Let's get one real quick. Now, the good news is that I have graph paper. Not really good news for you guys, I suppose. Let's say I have this triangle. And we'll call this guy, I'll move it down even. Now, I'm going to try to do a mirror image as best I can because that's going to make it really easy. Okay, let's say I have these two triangles, and I didn't really make it easy on myself, but that's okay. Doesn't have to be perfect. Those look believable to me. Let's say that I have triangle ABC. And then over here is triangle QMP. In this triangles, these two triangles, they certainly look kind of congruent to me right now. When we are using this, the order matters. So just so you guys know, we'll have side angle side, which is what we've already discussed here. SAS, we will have others. We'll have 4 in total by the time we're done. One of them we won't use in here, and it'll be very clear that we don't use it. But looking at this, let's just start putting marks on our pictures. I need to have 2 sides and 1 angle that's included is what I say. So check this out. AB, if I put a dash across this, what do you want it to be congruent to on the other one? So QM I don't think matches. MP. Everybody, like, just purely from seeing it looks like a reflection. Now, all I need is 2 pairs of sides. Here's one of them. I don't care which other one we go with. Let's just for now say it was AC and QP. Now, right now I have 2 sides congruent to 2 sides of another. What I haven't included yet, no pun intended, was the angle, the included angle. Now, there are 3 angles on this triangle. What does your gut say, Vincent, is the one that I'm going to consider the included angle, do you think? Any thought? A, B, or C? A. You didn't sound very confident. Anybody else think A? Now, we would call it included because which 2 sides is it between? The ones that are marked, right? It's included in there. These are the angles that we're after. If you have just this much information, and notice it goes between 1 dash and 2 dash. So 1 dash, arc, 2 dash, 1 dash, arc, 2 dash. We'll make sure the order is there. If you give me this picture, where I'm just going to be really specific and we'll define, or just at least draw that, included angle, it is between those sides. So we'll do one there and do one there. Between means included. Okay, what do you think we conclude about these 2 triangles? So here's our if. If we're given this, then what's true of the triangles? They're congruent. Now, here's the hardest part. When we're writing our congruence statements, remember the order matters, and it is really important. What we call the first one is irrelevant. I'm going to start with triangle BAC, and I know that that feels like a wonky way to go, but let's make sure we can line this up. You are going to hear me use dash for these marks. The congruent sides I mark with a dash. This is an arc, not an arch, an arc. So when I run through BAC, there's a reason that I did this. Do you agree that I go 1 dash, arc, 2 dash? B to A to C. I go across 1 dash, then I hit the arced angle, then I go across 2 dashes. How do I go 1 dash, arc, 2 dash on the other triangle? Boom. MPQ. Our order must be in this orientation, which is a weird thing to say. Now, you don't have to write these, but I just want to make sure that we can practice a little bit with that. These light blue ones, entirely up to you if you want to write it. Like, doesn't add anything to our theorem. What if I said triangle cab? How would you explain how I'm going through this triangle? So I agree with you. Like, and some of us will see it really quickly. Some of us, it might take a little practice. If I go CAB, I go 2 dash to arc to 1 dash. Everybody agree with that? So if I go 2 dash, arc 1 dash, it must be QPM. And I can see CAB, 1, 3, 2, 1, QPM. And we can match them up always. The order matters every time. Your first triangle you get for free, just like with slope stuff, but be comfortable with moving the order. Does this theorem seem crazy? Does it seem obvious? Should we prove it? Okay, your book, and I hate the way that they do this, when they say, yeah, let's prove it, remember that when we started talking about congruence, their definition and the book definition that we've talked about same shape, same size, or does there exist a congruence transformation? What is a congruence transformation between these? It's a single reflection, right? Like it does exist. I can see it's there. I wish that they did more formal proof. We're not going to prove this one. Okay. We're immediately going to get one more theorem, and then we're going to do another proof together, just to kind of get back into the swing of stuff. This next theorem, I've never taught it as a theorem, and that's fine and dandy. I kind of like that blue color, so I'm going to use that. So if I say what's one shortcut for triangle congruence, you guys can talk back and you can give me a little what? SAS. I'm cool with it. Okay. SAS, the order matters. We get another theorem immediately. And theorem 4.4, I'm going to write the shorthandy version of it. That is, it's going to seem like a made-up Holloway shorthand, but I promise it's not. We're going to work out what these letters mean. C, P, C, T, C. For real. Like, I promise, CPCTC. Now, this one is pretty natural. If I looked at these, and I just told you these triangles are congruent, should corresponding parts of these triangles be congruent? So what I mean by that is the angle, if I go from arc, or single arc to dash to empty, it'd be angle B. Like I can identify, or dash to no dash, it's B. If I go dash to no dash, it's M, right? Do these match up in my statement? B and M, they should be the same. Okay, so for this theorem seems so silly, it's going to be really easy to write out. I'm going to write out the words once. You will always use CPCTC. What are those letters? Check it out. Now, I won't typically say these letters. Instead, I'll say the real phrase. This is short for exactly as follows. Corresponding parts, which just means they're in the same place. Now, they could be rotated, so we have to be careful with it. We follow our congruent statement. Corresponding parts, and I'm going to capitalize each of these first words. Of, I'm not going to capitalize. Corresponding parts of congruent triangles are, I'm not going to capitalize, congruent. Now, I have very intentionally capitalized and left lowercase specific words. CPCTC, corresponding parts of congruent triangles, are congruent. Now, we use this constantly, and it seems so silly that we would ever use this, but right off the bat, I'm just going to make one follow-up comment. We're not even going to have a picture for this one. CPCTC, corresponding parts of congruent triangles are congruent. We use this specifically. We use this to show one part of a triangle is congruent, and that doesn't look like a triangle, it looks like an A. One part of a triangle is congruent to another part of another triangle. Gross. Okay, now there are two different types of proofs that we're going to see, and there's a reason I make this statement. There's the flavor of proof where I say, here's all this information, show me the triangles are congruent. Or I can say, here's a bunch of information, show me that angle A and angle Z are congruent. That is this situation, the CPCTC. Corresponding parts of congruent triangles are congruent. All right. Everybody, I want you to stand up. You're going to do a quick walk around the room because I can feel it's getting blah. Just one quick lap, just do a circle. I'm going to get some candy, and I'm going to ask you some questions, some Holloway trivia. Real quick, just for a brain break. We going to do a proof. So we will use this theorem in this proof. I guarantee it. I have a feeling we'll also get a little sassy with it, but we'll see how it shakes out. So here we go. Our example, and this is likely going to be the last thing that we do today. I'm going to try to give you a short homework tonight in hopes that tomorrow's assignment is less long. Like, only reason that we would do it. We'll see if we get there. Okay, for the following figure, I want you to help me show that angle Bravo is congruent to angle delta. Now, Really important because it's been a while. Remember, I could write show or I could write prove. They're the same thing. Now, we have to have pictures. When you guys get proofs on your homework assignment, if you don't draw the picture, I'm not going to give you credit. Cool. It can be a lazy picture. It doesn't have to be to scale and be perfect. I'm cool with that, but I need you to draw it. Now, I'm going to try my best to sketch this well, but it doesn't have to be perfect. Does not have to be perfect. I'm going to try to draw a parallelogram. And it's been a while since you guys talked about shapes. This is a parallelogram. And I'm going to name this Alpha on the top left, Bravo on the top right, Charlie on the bottom right, and Delta on the bottom left. And then I'm going to add a single diagonal across this from A to C. Okay. So we get a parallelogram, and we're trying to show that two angles are the same. Now, coincidentally, if you haven't noticed yet, when I added that diagonal, I took my parallelogram and I made it into two whats?
Triangle.
Weird way to say triangle, but I agree. Now, if we're trying to write a proof, you need some given information as well. Would you rather I write the given information formally and say, here's what you're given, or mark the picture and then make you help me decide what was given? Okay, so here it is. I'm going to put the following marks. I put little arrows on AB and DC, and then we're also going to put a dash on each. Okay, this is it. Every single proof that we ever do has to start the same way. What's the first thing that we do, Camille? Write the givens. Now, I happen to give you the givens just on the picture this time. Raylene, can you tell me what either of these marks mean? When you say they are congruent, what segment is congruent to what segment? Or which, rather? AB and CD? Okay, so check it out. AB as a segment is congruent to, I would call it CD, and I know it feels weird because we're going the opposite order, but I think that's how I would write it. And beyond that, Vincent, what do these little arrows mean? There's a mark between them that I can also add. Are they ever going to cross? That's the word. Parallel. What's the symbol for parallel? Two lines, or segments at least. Okay, here's all we know. AB is parallel to CD, and they're congruent. That is my given info. Now, finally, we get a way to start adding some stuff into the proof that we haven't had before. We've never had to do it. Right now, how many shortcuts for triangle congruence do we have? Just one. And what is that one shortcut, Andrew, that we've already talked about? The one shortcut, the one theorem that we started with today. SAS. What does SAS stand for? Side, angle, side. Do you guys agree there's two triangles up there? Do they have one side congruent? I need two sides congruent. Does there happen to be a side that's on both of these triangles? And it feels so silly to do, but what side is on both triangles? Everybody agree that this side is on both triangles. And this is the first time that it's made sense to do this. I don't know why I'm changing color. And it feels so odd to write. But if we mark something, we have to be able to write it. AC is congruent to what? It feels odd. AC or CA. I would take either, Andrew. That is true. And this is the first time that we've truly needed to have this. This, you might not recall, is the reflexive property. Something is congruent to itself is always true. Now, notice, I marked the picture. If you've not marked it, you should. Right now, I have two sides congruent. If only there were an angle that I could write. Here's what I want you guys to do. This is your quote-unquote assignment. I'm going to make the following claim. I think I'm going to add some numbers here, first of all. I'm going to add a 1 up here. I'm going to add a 2 down here. because I think I can say with confidence that angle 1 is congruent to angle 2. What I want you guys to do is give me the reason C for why I'm confident. On D, I want you to write your similarity statement. And then on E, I want you to finish the proof. If you do more or less than C, D, E, I'm okay with it. But when I finish this, I'll have 3 steps. Tomorrow at the start of class, I will check to see that you have attempted. Not necessarily correctly, but I will check to see that you've attempted as a 1-point homework. All right. Peace out, A-Town. No homework this evening.